Buongiorno. Il prossimo ospite ha avuto come scopo della vita e della ricerca progettare una migliore interfaccia tra uomo e computer. Fin dai tempi in cui lavorava al MIT Media Lab, che è uno degli istituti di ricerca scientifica e tecnologica più famosi del mondo, a oggi in cui è proprietario di un'azienda che si chiama Oblong, ha sempre progettato soluzioni talmente futuristiche che l'hanno chiamato come consulente scientifico in film come Minority Report o Iron Man, film in cui l'interfaccia appunto uomo-macchina ha soluzioni tecnologiche incredibili come comandi gestuali, multischermi, ologrammi e tante altre soluzioni che oggi incredibilmente sono realtà e di cui ci parlerà nel suo prossimo intervento, che sarà, ricordo, in inglese, quindi chi volesse può scaricare la nostra app per avere la traduzione simultanea. Io chiamo sul palco John Underkoffler.
Are we live? Buongiorno. No? Anything? Yeah? Is it good? Are we hearing anything? I can speak very loudly. Mi dispiace che oggi debba parlare nella lingua sbagliata. And unfortunately, you're just going to get English for the rest of the time. I'm sorry. My translation chip is not working today. So my message here today is actually very, very simple. And that idea is that user interface is important. In fact, it's very important. In fact, it's incredibly important, and it might be the most important thing in technology today. And the problem is that no one's thinking about it, and no one is doing anything about it. So let's get right to it. This is me. In case you agree or disagree, you can yell at me here, and many do. So to understand why a user interface is important, we need to understand that user interface is a language. It's the language that we use to talk to computers, and that computers use to talk to us. And as with any language in the world, Italian, English, Portuguese, whatever it is, the vocabulary plus the grammar defines what can be said. And if that definition is too small, then there are many things that can't be said. And as I think you can expect, my idea today is that there are too many things that we cannot say with user interface currently. At the same time, the user interface is incredibly important because for us, as human beings, it is the whole computer. Maybe there's very interesting things happening inside the electronic brain of the machine, but we can't see them. The only thing that we can see, and the only thing that we can touch, and the only thing that we can interact with is the UI. That is the definition. And therefore, for us, as human beings, the UI is the computer. So it's a little bit Wittgenstein here. Die Welt ist alles, was der Fall ist. The world is everything that is the case, and sometimes, for Wittgenstein, language was everything. For us, and maybe that's not true in the real world, but in the computer world, it is literally true. There is only the user interface, and there is nothing else. So, we need a way to grade user interface. We need a way to evaluate it. We need a way to tell UI, is it doing a good job, or should it improve? And the way we will measure user interface is by how much it lets us express. How much can I say through the user interface? Can I take ideas in my head and get them into the computer? I think you know what my assessment is going to be. So to understand where we are now, we should understand where we came from. So the history of modern user interface is unfortunately a very small story, even though it occupies a lot of time. The first thing that happened, well, in prehistory, computers were big, incredibly expensive, and very, very rare. If you wanted to use a computer, you probably had to be in a university or a big company. And then this happened. Suddenly, many people could have computers. Almost everyone could have computers, and this computer uses language in, you type words, and words come back out into your eyes. So it's a primitive UI, but the fact that everyone can experiment and build things transforms the world. The next thing that happens is that we go from the language part of the brain to the picture part of the brain, the spatial part of the brain, because in 1984, the Macintosh teaches computers to speak in pictures. And this is amazing. Now 100 times more people can use computers than was possible before. Not much else happens. This is the biggest moment. This is the best moment that UI ever had, because this is the user interface that we still use today. The next step is actually backwards motion, because the next thing that happens is that we use the web. We invented the web, maybe in 1994. And this is incredible, because now not everything has to be on your computer. Instead, information can be out there, and everywhere, and you can get to it all. But the user interface may only live inside the browser. And it is a very, very primitive user interface. If this is the Macintosh in 1984, and this is 1994 with the web browser, the sophistication actually went back more than 10 years. One more thing happens, which is that we teach computers to be portable. We get to take computation with us. We don't call this a computer, but it is. And that's incredibly powerful, except that the UI gets even smaller. So we can say even less, and we can understand even less. That's a lot of time. That's almost 40 years of kind of forward and backwards and sideways. Is that okay? I think it's not okay. You know what? I'm tired of bending down. I'm just going to sit now. We use the word political in the title, and here's a little nod to the political idea. In the book 1984, George Orwell had an idea called Newspeak. It was a fictional language invented by the government that had many words taken out so that people could not express dangerous ideas. This doesn't work in the real world, but what we have today is a user interface that is missing many, many words. So we cannot express enough ideas, and I think this is a problem. And one more idea, if you think about it, we are still using today a user interface that was designed for a 1984 computer. But here it is, it's 2018, and we have adult 2018 brains that are amazing, and the machines have 2018 electronic brains, and they are very, very good, but we must speak in a childish language designed for 1984. And that's a problem. So what I would like to do is propose 8 different ingredients that we can bring together into a recipe for a new user interface, a second generation of UI, because we've only had one. Let us go right into those. The first idea is that we would like to break open the display, break the pixels out of that plane, and let them go everywhere into the room. And when you do that, you get something like this, where the computer can project pixels, like maybe a wind flow simulation, and human beings can take pieces of the real world and put them inside the simulation. So we're bringing the computer world together with the physical world, and in that join, something very amazing happens, because we let people use their hands, and hands are very, very wise objects. They are where intuition comes from. So by experimenting with spatial ideas in a spatial domain, we have a geometry idea, we can move a building to see what happens to the shadow. That's incredibly powerful. And that cannot happen inside the computer screen. It needs to happen in the physical world. The second piece is that we need computers to understand that there is a physical world. This is a magnificent space. But these pixels on this screen don't know about this space. They don't know about you. They only know about a very sad, flat world. We want to make that world three-dimensional, and we want to make it so that people can use their hands again. They can use their hands to point and step back from the screen. And by pointing, you can grab information, move it around. Action at a distance. And because you've stepped back from the screen, now there's more space. There's space for friends, for collaborators. There's space for collaborative interface. More than one person using a computer at the same time. We can fly through data. We can use touch, which is just a special kind of gesture. It's where you come into contact with a surface. And this is very advantageous if you need friction, if you need precision. But you can bring your hands up as well. In this case, you can reach out and you can grab pieces of data and bring them forward and understand them the same way that you understand pieces of the real world, by using your hands. Sometimes the pixels move under objects. Sometimes the pixels are physical, like in this case the drone, which uses the same gestural language. And maybe most importantly of all, after pointing, is navigation. So we can fly through three-dimensional space, and it's an amazing discovery that one hand can control flight, X, Y, and Z, and also pitch, roll, and yaw, like that. So you can get to anywhere in a space, and you can look in any direction just with one hand. When you take visualization and bring it together with navigation, it means that new kinds of intuition are possible. And we can build very, very sophisticated systems that use these new hand and space intensive techniques that work much more easily, that people can learn much more quickly, that let more information come into people's heads all at the same time. The next idea is that we've been building very strange computers. Whether your computer looks like this, or a tablet, or a laptop, or a desktop, we've been building them so that all of the interaction and all of the computation stops at the physical edge, the physical boundary of the device. That's strange because the network goes everywhere, but we're saying, no, the device is only that big, so you only have that much computation. Instead, we must teach the machine to let computation go outside the boundaries. And this is important because that's what we want as people. In this example, you see a little bit of art, a fresco, running around 5 different displays. Those displays are being driven by 3 different computers that are running 2 different operating systems. And that's hard for the computer to do, but it's exactly what the human wants. Because this person doesn't care that this is Windows, and this is Mac OS X, and this is Linux, and this is a small screen, and this is a big screen. This person just needs to see and understand. So we need the pixels to work together, and that means the computer needs to understand space. It needs to understand where the pixels are so that it can create one continuous display and interaction space. Another example of that same idea here, we can take a little piece of data from a small laptop running Mac OS to a giant screen running Linux and bring a different piece back and interact all throughout the space. Again, space is the important ingredient. Space is where we are experts. We want computers to work just like a wall, where we can take a picture that's stuck to this piece of the wall, walk over here, and put it in a different position. Position is important. It's how we understand. Let's make computers work that same way. The other big complaint, I have many complaints about this, as you can tell. The other complaint is that it's small. It needs to be small so that it's portable, so that we can take it with us. But because it's small, we can't see much. And, you know, maybe this is enough space for us to see a shopping list. Maybe it's the right amount of space to check traffic. That's good. That's a small task. What if you're designing a city? What if you're designing traffic flows in a city? What if you're working to plan a brain operation? I hope you don't use this. And it's not because it's a bad device. It's just because it's not big enough. You can't see enough. And so what we need is not just one size of computer. We need many sizes. And we need to get comfortable and smart and adept at building and using large visual and interactive spaces. This is our experimentation warehouse in Los Angeles. If you visit, you can come take a look. And we experiment with enormous displays there. So in this case, there's a complete room that is filled with pixels, and this researcher is able to fly through a city. Now, you could also use Google Maps to look at a tiny piece of that same city on this. But I guarantee that what happens in your brain is very different. Here, you're just seeing a little bit of information, but your brain and your eyes are very, very happy to see lots of information in parallel, side to side, top to bottom. You're very, very good at seeing in parallel. That's why this space exists the way it does. That's why this space is large instead of small. That's why all of these paintings can exist at the same time, because we can understand them. And we have to build digital spaces that can give us information at that same rate and at that same scale. This is another example. Similarly, it is a biological example. These are individual cells in an embryonic quail heart, a bird heart, over 6 hours as the cells move through space. But something new happens when you can see the data at this enormous scale. You're not working like this. Your evolutionary brain is now existing at horizon space, at ambulatory space. This is how you understand cities. This is how you understand landscapes. And it is possible to understand data this same way. We must study cinema. Cinema is an important and unique human invention, a language that's 120 years old, maybe 130 years, and it is uniquely good at describing space, at describing the movement of bodies and situations through space. Cinema describes causality, first this, and therefore this, and as a consequence, this next thing, and because of that, this. That is an incredible language. But for 130 years, cinema has been one direction only, from the screen into here. This is an experiment that says, what if we could make cinema two-way language? What if you and I could speak cinema? What would happen then? Maybe something like this. A system where you can navigate through movies, many different movies, go to an individual piece of cinema, navigate through time within it, find something interesting, a character, a prop, a vehicle, and grab it and bring it to you, isolate it, bring it out of the movie. Go to a different movie, made in a different country at a different time, bring a new piece of information and combine it with the first piece. By combining things, by combining new ideas, by combining different ideas in the same space, in the same mind, we invent new things, we discover new things, we learn new things. And so we must make sure that our digital systems, and therefore our user interfaces, give us access, give us power to do this with all of our digital stuff. It's your digital information. You should be able to take it apart and put it back together in new shapes and new forms so that you can invent and learn new things. Now, at every technology conference, it is important to talk about Minority Report. Everyone does it all the time. We can't stop it. It will happen for another 30 years, and I'm sorry about that. However, since I designed all of the technology for the film Minority Report, which was kind of an accident, I'd like to suggest that we think about it in a slightly separate way. For me, working on the movie, designing future user interfaces 50 years advanced, was fun. It's an entertaining movie, but there was something more important that I was trying to do. For me, Minority Report was an experiment, a way to show people what computers could be like, a way to ask people, would you like to use a user interface that makes you more expressive, more powerful? And after we designed these systems, and we designed the hardware, we designed the language. This is a training manual that I made for the actors so that they could familiarize themselves with the gestural language, and I spent weeks training Tom Cruise and Neil McDonough and Colin Farrell. What happened was this, and it turned out to look very realistic. And this is the experiment. In this experiment, what we see is not magic. We're not looking at AI. We're not looking at a magic computer brain. We're looking at UI. And very, very talented detectives can put this UI on their bodies like a suit to extend their capabilities. In this case, they have to sift through tens of thousands, hundreds of thousands of pieces of information to put together clues to stop a crime. And only through this UI can they do the work. They can't do it manually. There's no AI to help them. They have to use a user interface that brings them together, that expands their minds, and lets them collaborate in one space. And because the result of the experiment was successful, we formed Oblong Industries. And in fact, Oblong's first product is a system called Mezzanine that is that same idea. It's just like Minority Report, but it's for use by collaborators in business and science and engineering and government and organizations of all kinds. And it does one new thing. And this is very important. Every computer that you've ever used in your whole life, whether it's a smartphone or a tablet or a laptop, is for one person, only you. Your computer doesn't know about anyone else. Its user interface only talks to you. It only thinks about you. That's a problem. That's like a city full of buildings which can only accommodate one person. Imagine if this palazzo looked just the way it looks today, but only one person can come in at a time. That's a terrible waste. We can't meet, we can't talk, we can't learn new things. But we've been building technology, and we've been building computers, and we've been building user interfaces in that same way. And we need to build multi-occupancy computers that are just like this room, where many people can come in at the same time. And that's Mezzanine, just like Minority Report. Lots of people working in a space, talking to each other, but also talking to the computer. Many people can take data, programs, applications, documents from their personal device and put it in the public computer, the Mezzanine computer. It is an architectural computer all around the room. And by putting it in the public computer, everyone can see it, and everyone can interact with it. And all of it's parallel. I can put my stuff in it, but you can put your stuff in it. And she can put her stuff in it. And someone who is joining us from Sao Paulo can put their stuff in it. And so we all see the same thing at the same time in the same way. And if we forget about computers, that idea is what collaboration is about. It's about people seeing the same things in the world, but also in their minds, establishing the same context, and then working together to solve problems. I'd like to show one more example. This is an amazing data set, a data set that is a scan, many scans put together of this city, of Firenze. And every road, every building, many trees, every part of the city space exists inside this database. In this example, what we will see is many computers all looking at the simulation, all looking at the city at the same time. Of course, they can each look at different parts of the city, but what's new is that they can tell what other computers are looking at. And let's see if I have a cursor over here. So you see that mouse pointer. We all know the mouse pointer. That mouse pointer is me. That's all I am. Inside this user interface, this 1984 user interface that we all must still use, that is the only representation of you. That is what the computer thinks of you. Now, if you and I are using a system together, it's a collaborative system, then maybe there are 2 cursors. And if we have 3 more collaborators around the globe, then there are 5 cursors. The cursor is not enough. We have to open it, we have to expand it to show what other people are looking at, what they're thinking, what they might be wondering about. And so in this system, we have a giant wall of pixels. We have a small laptop. And on the giant wall, you see a rectangle. That rectangle shows us what the little laptop is seeing. As it moves on the laptop, the rectangle moves around and rotates on the big display. As it zooms in, the rectangle gets smaller because it's seeing a more zoomed in piece of the city. But you can take the rectangle and move it. It's like you can grab someone's eyes and move them. And that's important because if I know that you're looking over here, but maybe the Duomo is on fire, we have to deal with the emergency over here. I know you didn't see it because I know you're looking over here. So I can take your view and bring it over here. And so this little piece of UI is a first step toward cognitive empathy. I need my mind to be connected with your mind so that we can work together. I need to know what you're seeing and maybe what you're thinking. These are new techniques that we will bring to bear in the future. And so to finish, I'd like to say that if you design user interfaces, I'm going to recommend something new. I'm going to recommend that you stop thinking about computers. I'm going to recommend that you stop thinking about user interfaces. It's a waste of time. We're already at the edge by thinking about the same thing again and again and again. What we need instead is to think about everything else. And we have a whole alphabet of things to think about. We start with A in the alphabet. A is for architecture. A is for architecture by Piranesi, by Etienne Louis Boulet, by Lebbeus Woods, by Raymond Abraham. These were architects who said, yes, 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 we know what a house is. What else can we do? What else can architecture be? How strange can it be? How can it change the way that we work and think and interact with other people? This kind of architecture is important. B is for biology. Tensegrity is the mechanical structure that keeps cells in their shape, but it also is a mechanical communications mechanism between different cells. Protein folding, the shape and geometry of molecules affects our chemistry, affects our health. The action plant, an interesting book, you should check it out. Rhizomes, enormous communications networks below the ground that connect grasses and trees. And consciousness itself. Of course, we are biology, we are animals, and somehow our biology decided to build a computer. And we should understand that too, because it's very beautiful. C is for cinema. We already looked at cinema a little bit, but these are people just like the architects. Maya Deren, Hollis Frampton, on and on. Terry Gilliam from yesterday. These are people who said, yes, yes, we invented cinema 130 years ago. What else can it do? How can it make us excited? How can it make us exhilarated? How can it give us new ideas? We must study this. And fortunately for you and for me, you can imagine D, E, F, G, H, I, J, K. We won't do it here. For the rest of you, if you're not a user interface designer, I just have this request. I would ask that we not just wait to see what new products, what new technologies, what new devices come to us. I think we have to demand an adult language. We have to demand not to speak childishly between adult humans and adult computers. We have to demand the user interface that we want to use. Grazie.